Welcome to Mrs. Childress's Chemistry Concept. Today we're going to discuss density. And density is an interesting concept because it can be taught to most any ages. Even the little ones can understand teaching things like buoyancy, floating, and sinking. But today's chemistry concept is going to be geared more towards middle school or high school. And we're going to look into more of the mathematics behind density and a definition, of course. So let's start with the definition. So the basic one is that density is defined as mass per unit volume. And density is what we call a derived unit because it is taken from two other units put together. So the unit of mass and the unit of volume together gives us the idea of density. Another definition that's often used is density is the ratio of the amount of material to the volume it occupies. And that is why we often look at floating and sinking, because we compare densities, and if one density is higher than the other, then it's going to sink. If it's lower, then it's going to float on that liquid if we're talking about a liquid environment. So we're looking at how much volume there is and how much mass there is, the amount. So the formula for density, of course, is going to take into consideration both mass and volume, and you can see it on the screen as density equals mass divided by volume. So you can solve for density either if you have mass and volume, you can measure to find the mass and the volume, or maybe you're given that in your problem. You can also solve for mass if you have the other two components, or you can solve for density in that way as well. So what we're going to do is look at the example in front of you. And what I have in the bottom right-hand corner is something I like to call the density triangle. And this actually helps us to use the density equation very easily. And so let me get my pointer. And we'll look at this together. So what is the density of carbon dioxide gas if 0.296 grams occupies a volume of 100 milliliters? So for this case, we're going to solve for density by taking mass divided by volume. So here's three other examples. A block of wood, 3 centimeters on each side, has a mass of 27 grams. What is the density of the block? Well, in this case, we're not given volume, but we are given enough information to find volume mathematically. And of course, we can take a block and we can measure volume by side times side times side, and that would give us the 3 times 3 times 3. So we put the 27 grams, which is the mass, divided by 3 times 3 times 3, and our final answer is 1.0 grams per centimeters cubed. Now you'll notice that the mass in this situation is grams and the volume is centimeters cubed because we took the length centimeters, we cubed it to find the volume in that situation. Here's another one. 5 milliliters of ethanol has a mass of 3.9 grams. And 5 milliliters of benzene has a mass of 4.4 grams. So in this case, it's asking which liquid is denser. So we would have to find the density of both of these liquids to then be able to compare them. So the first one, we take 3.9 grams divided by 5.0 milliliters. And that is a total of 0.78 grams per milliliter. Now you notice the unit here is milliliters because that's what our volume is in. For the other density of benzene in this case, 4.4 grams divided by 5.0 milliliters, and we get a total of 0.88 grams per milliliter. So the denser material is the benzene. And our last equation, a sample of iron has the dimension of 2 centimeters times 3 centimeters times 2 centimeters. If the mass of the rectangle-shaped object is 94 grams, what is the density of iron? So here's another one, similar to the first example, where we are given the dimensions in centimeters, so we're going to do that. And we also have the 94 grams. So 94 grams divided by, and you can see the 2 times 3 times 2, giving us a total density of 7.8 grams per centimeters cubed. So that's an easy way to find density. And soon you will find a video as well on, in the laboratory, how do we find density? And that's a very fun one, so be watching for that as well. Thank you for watching.